Hi, today we will solve problem to find median of two sorted arrays. So for example, we have one array as 1 and 4, and we have second array which is 2 and 3. So we need to find median of those two arrays. We can solve this problem in one way, to sort two arrays and then find median of one big sorted array. So in this case, our complexity is going to be O x plus y, where is x size of first array and y size of second array. And space complexity as well is going to be O of x plus y, because we are creating new array. Instead, we can find more optimal solution to solve this problem in a log of minimum x or y. So basically we can do binary search on a smaller array and find median. So how we're going to do that is we will split our first array or smallest array somewhere, for example in the middle, and then split second array accordingly. So after split we'll have same number of elements on the left side and on the right side. So I'm splitting first array in the middle, and because we have two arrays with just two integers, so we're splitting the second also in half. After split we're getting two elements on the left side and two elements on the right side. So after we found those two split positions, we need to compare elements. We need to compare first element, left element on the first array, and the second element, right element on the second array. And we need to check that left element is less or equal than right element. So in our case, 1 is less or equal than 3. And then we need to check that left element from second array is less or equal than right element from first array. So in our case, 4 is less than equal, 2 is less than equal than 4. So if our conditions met, that means on the left side, all elements will be less or smaller than all elements on the right side. So we have 1, 2, 3, 4. So we can guarantee that all of these elements is less or equal than all elements on the right side. And now to find median, we need to get maximum element from left side. So we need to find maximum of 1 and 2, and then minimum from right side. So we need to find minimum of 3 and 4. So we're getting maximum 2 here and minimum 3, and our median is going to be equal 2 plus 3 divided by 2, which is going to be equal to 2.5. Okay, so this was first example. Let's take another example and repeat one more time. Take array 1, 3, 6, 2, 4, 7. So from example before, we know that we need to split smallest array, first array, somewhere in the middle first time, and then check if elements on the left side is less or equal than elements on the right side. And when we split, we have multiple split positions. So in our case, with an array of 3 elements, we can split position 0, 1, 2, and 3. Let's split first array at this position. And we know that we need to split second array accordingly, that left split portion should have same amount of elements. So in our case, we need to split second array here. So after splitting, we have 3 elements on the left side and we have 3 elements on the right side. Now we need to compare that 1 is less or equal than 7, which is correct. And then we need to check that 4 is less or equal than 3, which is not correct. 4 is more than 3, and that means we're too far on the left side of our split position. So that means we need to move our split position to the right on the first array, and on the second array we need to move our split position to the left. Let me erase previous split positions. And we'll split at this point, and the second array will split at this point. So now we need to check that 3 is less or equal than 4, and 2 is less or equal than 6. So we met those two conditions, and now we know that left side all elements is less or equal than all elements on the right side. And when we found this position, now we can find our median. So median again is going to be equal maximum between 3 and 2, between those two elements on the left side, and minimum of 6 and 4. So we have 3 plus 4 divided by 2, we've got our 3.5. Let's move to next example. So next example, let's take 1, 3, 5, 8, 2, 4, 7, 9, and 10. So in this case, our first array is smaller, so we will cut it, split it in the middle, and we have interesting situation. So our second array has odd number of elements, so we cannot split it in half. So in this scenario, when total number of elements of two arrays is odd, we will split in such way that extra element is going to be on the left side. So we will split second array here. So after split, we have 5 elements on the left side and just 4 elements on the right side. So in this case, if we have an odd number of elements, our median is going to be maximum element of the left side, on the left side, right? Because we know that left side has 1 extra element. All right, so now let's check if we split it at correct positions. So we have 3 and 9. 3 is less than 9, it's good. And we have 7 and 5. And 7 is more than 5. And because 7 is more than 5, so that means we need to move our split position of first array to the right and split position second array to the left. So let's clean up our previous split positions and split it at this point and here. So now we have 5 is less than 7 and 4 is less than 8. So we found our split position and now we know that all elements on the left side is less or equal that all elements on the right side. And our median is going to be maximum between 4 and 5. So we compare 4 and 5 because we have odd number of elements. So our median is going to be just one single element. So in our case, we have 5. So 5 is our median. Now let's take same array, but we will use formulas. So first we'll need to store our x. So x is going to be equal to array1 dot count. Then our y is going to be equal array2 dot count. Then for binary search, we need to keep tracking of left position. From beginning is going to be equal to 0, and right position is going to be equal to x, size of first array, which is smallest array. Then we will need to keep track of our split position. So position x is going to be equal left plus right divided by 2. And position y is going to be equal x plus y plus 1. So we need to add 1 to take care of odd number of elements. Divide by 2 and then minus position x. All right, so we'll use these formulas to do binary search for our problem. Now let's take same example as we did before. So we have 1, 3, 5, 8 as a first array, and second array is 2, 4, 7, 9, 10. So now let's calculate what is going to be our position x. So position x is going to be equal left plus right. So left is equal to 0, right is equal to 4. So we have 4 elements. Divide by 2 is going to be equal to. And the position y is going to be x plus y plus 1, which is 4 plus 5 plus 1, 10. Divide by 2, and minus position x, which is 2. So we have 5 minus 2 is going to be equal to 3. And let me add here split position for first array. So 0, 1, 2, 3, 4. And we have 0, 1, 2, 3, 4, 5. So we have split position second array. So we calculated that we need to split first array at index number 2, and position y is going to be index number 3. So now we know that 7 is more than 5. So in this case, we need to update our left position, because we'll do binary search now on the right side of our array. So in this case, we're updating left is going to be equal to position x plus 1, which is going to be equal to 3. Okay, so let me erase our previous split position. And we updated our left. So let's recalculate our position x and y. So position x is going to be equal left plus right divided by 2. So our left is 3 and right is 4. Divided by 2 is going to be equal to 3. And the position y will be 10 divided by 2 is 5. And the minus position x, which is 3. So we'll have 5 minus 3 is equal to 2. So we're dividing x at this point, and y split at y is going to be here. So 5 is less than 7 and 4 is less than 8. So now we just find median, which is going to be for odd number of elements, is going to be maximum of 4 and 5, which is equal to 5. So here's our answer with formulas. Now let's take one more example using formulas and a different array. So let's use array 10, 15, 20, 25, 30, and 35. And second array is going to be equal 1, 2, 3, 4, 5, and 36. So let's mark our split positions. It's going to be equal 0, 1, 2, 3, 4, 5, 6. All right. Our position x is going to be equal to 0 plus number of elements in the first array, which is 6. So we have 6 divided by 2 is equal to 3. Position y is going to be equal x plus y, which is 6 plus 6 is 12, plus 1, 13, divided by 2 is 6, and minus position x, which is 3. So we have position y is equal to 3. So we split first array in the middle and the second array in the middle. So now we check that 20 should be less than 4, which is not correct. In this case, we understand that we need to move our binary search to the left position, so we're going to update our right pointer. So our right pointer is going to be equal to position x minus 1, which is going to be equal to 2. And after we updated our right pointer, let's recalculate our position x and y. So position x is equal left plus right. So left is equal to 0, right is equal to 2. Position x is going to be equal to 1. Now position y is 13 divided by 2 is equal to 6 minus position x, which is 1. So we have 6 minus 1 equal to 5. And let's split our arrays at new positions. So we have position x at 1. It's right here. And the position y is going to be 5. And now let's check that 10 is less or equal than 36, which is correct. And 5 is less or equal than 15, which is also correct. So now we understand that all left side is less or equal than all elements on the right side. Now, because we have even number of elements in two arrays, so our median is going to be equal maximum between 10 and 5, plus minimum of 15 and 36, divide by 2. So we have maximum of 10 and 5, 10, plus minimum of 15 and 36, which is 15, and divide this by 2, we got our 12.5. So here's our median. All right, let's move to next example, where we're going to cover one corner case. Let's take one array, 1, 2, 3, and second array is going to be equal to 4, 5, and 6. Clean up our position x and y. So our position x is going to be equal left plus right, which is 0 plus 3 divided by 2 is 1. So our split position is 1. Position y is going to be equal 3 plus 3 plus 1, which is 7 divided by 2 is 3, minus position 1, so we get in 2. Alright, so we found our split positions. Now let's calculate that 4 should be less or equal than 6, which is right, and 5 should be less or equal than 2, which is not correct. So in this case, we need to update our position left. So we need to update left, and left we know that is going to be equal to position x plus 1. Left is equal to 2. Okay, so now let's recalculate x and y, position x and y. Position x is going to be equal to 2 plus 3, 5 divided by 2 is equal to 2, and position y, 6 plus 1 divided by 2 is 3, minus 2 is 1. Okay, so here's our new split positions. So 2 is less or equal than 5, which is correct. 4 is less than equal to 3, which is not correct. We need to move our pointer more to the right. We again need to update our left position, which is going to be 2 plus 1 is equal to 3, and recalculate our position x and y. So position x is going to be equal left plus right, which is 3 plus 3 divided by 2 equal to 3, and the position y after calculation will get 0. All right, so let's clean this up. So position x we split here, and position y is 0. So now let's check that 3 is less or equal than 4, which is right, and we need to compare these elements, but we don't have, because we reached end of array. So in this case, when we reach end of array, instead of empty element, we will use integer max, and on the left side we will use integer minimum. In this case, we will not hit array out of boundary error. When we found our split position, we will take maximum between 3 and integer minimum. So maximum is going to be equal 3, and minimum will be 4 and integer max. So we will get our 4. So 3 plus 4 divided by 2 will be 3.5. So here's our answer. All right, hopefully it's understandable. Now let's move to our Xcode and implement this code. All right, so here I created my median of sorted arrays class to do unit tests for our function middle, which takes two arguments, array 1 and 2, and return double. So let's first return 0.00, and let's implement first test. Let's give input let array 1 equal to 1, 4, as we touch first example. Array 2 is going to be equal to 2 and 3, and let median we'll call our middle and pass 2 arguments there. And last step, xct assert equal. So our median should be equal to 2.5. Okay, now let's move to logic to implement our binary search for first array. So first step, we need to check that smallest array is a first array. So we compare if array1 dot count is more than array2 dot count. In this case, we need to call our function again with just swap our arrays. So array2, which is smallest, will be first. Alright, so next let's implement x is going to be equal array1 dot count, let y array2 dot count, then 2 variables left is going to be equal to 0 and right equal x. So next step, we'll do while loop, and the condition for while loop is going will be left less or equal than right. So until this, we'll do binary search, and inside let's calculate first is position x. As we remember, is going will be equal left plus right divide by 2. Then position y equal to x plus y plus 1 divide by 2. Remember, we need plus 1 to take care of odd number of elements in array. And then minus position x. So now we just need to find left and right elements on 2 arrays. So let's do left x will be equal to first array at position x minus y. So then let left y, left element from second array will be equal array 2 at position y minus 1. So next is let right x equal to array 1 at position x, and right y is equal array 2 at position y. Okay, so we found all elements, and now we need to compare that if our left x is less or equal than right y, and left y is less or equal than right x. So if this condition works, that means we found correct point for splitting our elements, and now we just need to calculate our median. First, we need to check that our total number of elements even or odd. So we'll do x plus y percentage 2 is equal to 0. That means we have even number of elements. So in this case, our median is going to be equal to maximum of left side. So left x or left y plus minimum of right y or right x. All right, so and it's complaining that cannot convert integer to double, so we need to convert maximum. We need to convert this output and the minimum output to double. Let's do it. All right, and let's convert this to double as well. Okay. So else condition, if we have odd number of elements, then we need to return maximum between left x and left y. Okay. So next step, if we didn't hit this if, then we need to check where we need to move our pointer, to the left or to the right. So if left x is more than right y, so that means if left x is a bigger element, then we need to move our pointer to the left. So in this case, we'll limit our search position right to position x minus 1. Else means that we need to move to the right portion of our binary search. So in this case, we're updating left, which is going to be equal to position x plus 1. And in the end, let's do return 0, 0. Or we can throw error here. So we need to return here as well. And return. Okay, so one more conversion to double. And now let's execute our test. We still didn't cover case when we don't have left or right elements when we're using integer minimum or max. We'll implement this in a second. Okay, our test succeeded. Let's use another example. So 1, 3, 6. Second array is 2, 4, 7. Let's run that one and see if it works. So we've got 0, 0, so it looks like we're returning from function. And looks like here's a problem. I don't need this return here. I need just one in the end, where I can throw, instead of return 0, 0, I can throw fatal error. Let's do fatal error. And we hit fatal error in case, for example, when array is not sorted. So let's do invalid input. All right. So let's execute this one more time. And I think output should be 3.5. Yes, so we're getting 3.5. So let's update our expectation. And now, so for test 003, I want to cover a scenario when we have 1, 2, 3. And the second array is 2, 4, 5, 6. So I'm expecting same median, 3.5. Let's run this test and see if it works. So actually we should hit, our function should crash and say we're trying to access element of array which does not exist. Yes, so we're getting fatal error, index out of range. We need to update all of these elements to use integer and maximum in case we hit out of boundary. So before searching for left x, we'll check if position x is equal to 0. And if it's correct, then our left x is going to be equal to integer minimum. Otherwise, it's going to be equal to array position x minus 1. And we'll do same for every element. Left y, we need to check if our position y is equal to 0. If yes, then we need to use integer minimum. Or if it's not equal to, if position y is not equal to 0, then we'll use this value. So for right x, if position x is equal to x, which is end of array. So if we're there, then we need to assign value as integer maximum. And same for last element, if position x, position y is equal to y, then we have integer maximum. Otherwise, array to at position y. All right, so let's execute this test scenario and see if it works. Okay, test succeeded. So looks like we covered all scenarios. Maybe just in case, let's do one more. Test 004. And where I want my input as one single element for first array and a single element for second array. And output should be 2.5. All right, excellent, works. Okay, all tests succeeded. So we solved this problem, find the median of two sorted arrays in O log of minimum size of array. Hopefully you enjoyed this video. See you later.